Welcome to another video. In this video, I'm going to obtain some interesting results of indefinite integral, that is cosec x dx. In the previous video, I have obtained some interesting results for secant x dx. I highly recommend all of you to watch that video first, then come to this video because I'm going to use similar method as well as most of the results are almost similar. As we know that cosecant and secant are just the complementary functions, therefore the result will also be complementary to each other. Therefore, I don't want to explain all in detail what I have done in previous video in this video, such that this video will be short. Without further delay, let's begin our discussion. We have that integral of cosecant x dx can be written as integral of 1 by reciprocal, because cosecant x is the reciprocal of the sin x, like that. And from here, what I will do is I will say 1 divided by sin x, like this, times I will divide and multiply it by sin x, like this, sin x, like this, such that the meaning of the equation doesn't change, but I will get some interesting expression. Therefore, I will get here sin x dx, like that on the top, and on the bottom I get sin square x. From Pythagorean identity, I can write sin square x as 1 minus cosine square x, like that. Now from this expression, I can use substitution method to further simplify or further aid our integration. Therefore, what I will do is I will say let 1 minus cosecant square x equals to t, such that my negative of 2 cosine x, negative of sin x, right, by chain rule, and the derivative of cosine x is negative sin x, will be equal to dt, and it will be positive, so I will get 2 cosine x sin x dx equals to dt. Now if you look very carefully on the top, I have sin x dx. Therefore, I have to isolate sin x dx from this expression. Therefore, I will get sin x dx equals to 1 divided by 2 cosine x of dt, like that. Now from this expression, I can extract the value of cosine x. Therefore, here our cosine x will be just 1 minus t whole root. Therefore, this will now change to 1 divided by 2 1 minus t whole root dt, like that. Now by using all these values, this integral will now change to integral of 1 divided by t times here half times 1 minus t root dt, like that, and it will be now half of integral of 1 divided by t 1 minus t dt, like that. Now from here, I want to use once again the substitution to continue our integration. Therefore, what I will say is here I will say let 1 minus t whole root be u, such that my u squared is now 1 minus t, and my t is just 1 minus u squared here. Now by differentiating this, I will get dt is equals to negative 2u du. Okay, by substituting these values, now our integral will change to half of integral 1 divided by 1 minus u squared is for 1 by t, and for square root of 1 minus t is just 1 over u, times our dt value is negative 2u du, like that. By using all this, we know that we will have negative of now 2 will get cancelled, u will get cancelled, so we will be left with 1 minus u squared du. And recall that from the standard result for the integration, we have that integral of 1 divided by a squared minus x squared dx will be just 1 by 2a ln of a plus x divided by a minus of x, like that. So by using this here, and our a value is just 1, therefore this whole integral will get reduced to negative 1 upon 2 ln of here my integral is 1 plus u divided by 1 minus of u, like that, plus c. And we know that we have this negative sign. In order to make it positive, we can flip this fraction and it will be just half of ln 1 minus of u divided by 1 plus of u, like that. And if you observe very carefully, my u value is root of 1 minus t, and my root of 1 minus t value is just cosine x. Therefore, whole of this will change to half of ln 1 minus of cosine x divided by 1 plus of cosine x plus c. And I can write this by raising this power and changing to square root, that my final result is just 1 minus cosine x divided by 1 plus of cosine x, like that, plus c. Okay, therefore this is the first result for the integral of this cosec x dx. Okay, now in the next video I want to further modify this and get more results. I hope you all would have enjoyed this video, and I will see you in next video. Thank you.